Fairly simple, fairly straightforward. I swear, everybody knows that. But the one that trips everybody up, if you are working with, say, arcs, there's 3 different options in the feature manager. Hit A. It cycles through them. Works for arcs, circles, slots. And then this is something that I will be very preachy about. Watch my cursor as I toggle through. It will do the different shapes. So you don't even need to look over there. Just pay attention to your cursor. And a lot of this stuff comes from paying attention to your cursor. Simple, you know. A, there we go. Next category, swords. Sorry, big wheel. All right, couple of little tricks here. Right-click, select chain. Everybody should know that. And S is the pop-up shortcut. If you're not using it, start using it. This has saved me so much time. I'm a huge fan. I preach about it. You know, just bear with me. So I'm going to do offset. I'm going to jump over here, cap the ends, bidirectional, make it a little bit more noticeable. Say OK. Now, because I use the S key so much, when I'm in a sketch, how do you get out of a sketch? You extrude or you cut. Put those on your shortcut. It's customizable. Just right-click on it, customize it. Real basic stuff. Nothing crazy fancy yet. Paying attention to your pointer. There's my mouse. Right-click, confirms it. Here's a little bit of trivia for you. It's kind of one of those forgotten things. I have 2 bosses. Is there a good way to convert a boss into a cut? Yeah. Grab the arrow. It's a cut, it's a boss, it's a cut, it's a boss. That's the way to do it. Oddball thing. So S is just not the pop-up. If you hit the S key and start typing, it activates the command search. So you hit S, it brings up the pop-up, but it also wakes that up. You could type in a command. If you click right here, it will take you into the command. If you click on the I, it will show you where the command's hidden, which is good for those ones that are really deep. And I've got my arrow back. There's a little glitch with the arrow, so I'm pretty psyched to see that. And all you have to do is click and you're in the command. Don't have to move your mouse or anything. Going to keep moving. Delightful. Enjoy. Puns. Okay. Does anybody use breadcrumbs? Or does anybody know what they are? Breadcrumbs are in the top left. They're really nice. It's not Hansel and Gretel GPS. This is an actual tool that you can use. What does D do? It brings them to your cursor. So you're not swooping all the way up there to grab them. You can get to whatever you need from right here. When you hit sketch, because it shows part, body, feature, face. If I hit on my part, drops down to sketch. I can come right up, edit the sketch, jump in and do my thing. If I hit D again, it brings confirmation corner down to my cursor. So I can just hit that, exit my sketch, and I'm done. So the way to think of D, it just brings top left, top right, down to your cursor. Everything's happening right in the middle of the screen or wherever your cursor's at. F plus, oh, I almost forgot. There's more cool stuff in there. It's neat for a part, but what about an assembly? So part shows your part, your body, your feature. In an assembly, when you bring your breadcrumbs over, it shows your mates. From here, you can just right-click, lock rotation. You can take care of all your mates without digging into anything. That's where it gets really cool. So F plus is still failing. This is kind of a light tip. We all know F just zooms at full screen. So I'll throw in G as well because people forget about that, the magnifying glass. Does anybody participate in beta? This was a fun one. The magnifying glass used to have a handle on it that left in beta because people thought it was a little hokey. So participate in beta and make your voice heard. All right. The F was really just a bridge to get us to shift of control. And these are more keyboard shortcuts, but it's not just the ASDFG. It's shift, alt, control, things like that. I'm a keyboard guy, just to give you an idea. That's what my keyboard at work looks like. So I use S, D, F, G, C, V. People hate coming to my computer because they can't see anything, so. And it's one of the goofy ergonomic ones. All right. Shift, alt, control, tab. All of these things have special functions. I call them modifiers. So say, for example, F, my bridge. Why is my F key so wore out? Alt plus F brings up the menus. These are just standard window shortcuts, but that's where I get a lot of mileage out of my F key. Tab key, this was one that I forgot about until I went to one of our VARs rollouts. With tab, you can just hide pieces in an assembly. I completely forgot about that. He did it during a rollout, and I said, wait a minute, oh man, I totally forgot about that. Bring it back, shift tab. But it's all based on where your cursor's at, and if you don't know where those parts are, shift control tab lights them all up so that you can just click on them. We'll keep going with these. Control drag copies. So grab this part, hold down control, wonder why it's not doing anything. Weird. Let's do this. What? Well, it's collapsed. What? Yeah, but it should still do it in an exploded view, because I could. Wow. Well, the handy one there was Control Z for undo. There's my part. Interesting. All right. It eventually worked. All right. I'm going to do the magic fix it. Not that. We're going to look at that later. I'm hoping it's not requiring the reboot. We will find out. There we go. So in my best FM radio voice, and we're back. When in doubt, reboot. This was one that it surprised me. One of the guys that I know didn't know about when you have a loose part in the assembly, it's not mated. When you hold your right mouse button down, it rotates that part. It's another one that I assumed everybody knew. Shift, Control, Alt. So if I grab Alt, that's going to activate Smart Mates. So I can do the pin and hole. I want to mate this one, grab that, drag it over here. I've completely mated that part with just modifiers. Alt, Control. Here's a really cool one. I dig this. When you do Control, it copy and drag, it copies. When you do Alt, it adds the mate. So Control. So just by doing that, I've copied and added a concentric and added a coincident mate. Cool stuff. This is one that, oddly enough, doesn't work well with a laptop keyboard. I ran into that the other day. I was planning on bringing a keyboard. So when your tree's all up like this, Shift-C collapses it. C is a pretty powerful one. Shift-C collapses, Control-C is copy. Control plus Shift-C is copy appearance. Alt-C is construction geometry convert. It's all in the book. It's okay. One of the things that I do when I leave a file, when I'm done with it, hold down the Control key. Number 7 is isometric. B is rebuild. S is save. W is close the window. So hold down Control 7, B, W, S, or BSW. You want to save it before you close it. So how do I know all these goofy things? If you dip into your keyboard, and I just go for keyboard and search shortcuts, hit the shortcut tab at the top, and it'll put them in order. So these are some of my favorites, just the numbers. Those are your views, because usually I'll have a 3D connection controller, and I have one of the buttons mapped to control. So I can just mash that, 1, 2, 3, 4. It's front, back, left, right, top, bottom, ISO, normal 2. You get into here, you get more of your complex. That was the temporarily hidden faces, Control-Shift-Alt. Just jump in, print the list, go through it. I won't bore you with it. All right, back to the top. Totally tubular. This is a little bit how to make it, and this is a little bit actual manufacturing methods. So I'm just going to draw a simple tube. That was my file new. Sorry. If I dip into this again, is anybody using mouse gestures? I'm trying to force myself to do this. I haven't been really good about it, but I'm doing it a little bit more. I'm going to start with this, and the reason I say it is because it goes by even faster than keyboard shortcuts. So let's get a sketch going. We're going to do a circle. We're going to dimension it. And then I put my shortcut key on my gesture so that I can just grab it. Now, everybody knows the mouse roll, zoom. If you hold down Control and your mouse, you pan. So I do a lot of that when I'm plugging through, like this. I'm going to do a thin feature. I'm going to flip it. Now I have a tube. Front plane sketch. This is one a lot of people forget. Click and drag when you're drawing a line. It just draws that one line segment. You don't have all the different, the rubber banding. All right, now the other one I'm going to throw in is if with your pointer up in the top ribbon bar, if you roll your mouse, it toggles through all of them. Right click, mid plane. I try not to move my mouse too much. I pay attention to the pointer. Right click, that's good. Go back to surfaces. I'm going to cut this with this surface. This surface, right click, yes. Click on this, watch my pop-up, hide. Control 1, there's my view. This is what a tube would look like when you're just cutting it on a saw, because it's going to cut all the way through the entire thing. The arrow keys will rotate it, so this just kind of gives you a better look at what it would look like. Now, let's change gears. I'm lucky to have access to really cool tools. So we have tubing lasers. They work a little bit different. The tube feeds out, the laser cuts through one side, the tube rotates, so the part looks a little bit different. Well, I can change this into a part that would look like that. I'm just going to grab these edges, or these faces. You want to grab the faces and delete them. I'm not going to delete and patch. I'm not going to delete and fill. I'm just going to delete. Hit the D key, confirm. Now I have a surface. If I thicken that surface, it gives me a completely different look because it thickens in. This is what it looks like coming off of the laser because it cuts it, drilling like it would go through the center of the tube, but only through the one side, and the tube's rotating. This isn't something you're going to cut on a laser. They would get really mad if I asked for it. But this is something that you would, because there's no way you're going to cut this with a saw. This is another thing I like. I have a hidden part, I click on it, it's shown so I can see it, and I can show you, hey, look, if you really pay attention to what you're doing, you can nest it really nice and get the most out of your tube. Like I said, I'm just throwing out a whole bunch of tricks. Now, how did we get the word on there? We had the company name, TMCO, hi, I'm Todd, wrapped around the front. How did we do it? It's a wrap. So I'm going to roll this back. I'm just going to keep using the same one for my example. On the front plane, I'm going to do a sketch. I'll do a slot for this one. And we'll just, something in the ballpark like that looks good. Jump up to my features, do a wrap, pick the surface. Now that's something you couldn't do on a saw. You need a tube laser for something like this. The first question, I used to work at a VAR, and I was teaching a class with a couple of guys from the company that I now work at. Very first question he asked, cool, what about square tubing? Ooh, well, let me see. Let's edit this sketch. And I'm just going to drop a rectangle in here. Drag it over, change this, and I'm using a lot of the pop-ups. Now the reason I left the circle there, I can still control it with that diameter, because that square is tied to the circle. Don't delete your geometry, keep it there. Throw a radius on the corners, and I'm just going to window the whole thing. This is that simple message that says, hey, you're about to break these relations. Yeah, I'm cool with that. My pointer has the check mark. I'm going to hit that, hit it again, hit D, and I'm out of my sketch. Get an error. I'm used to that. I like to break stuff. Continue along. Now the trick is knowing why I got the error. When I did the wrap, I had the cylindrical surface. I'm not using that. I put that to construction. So now I have this square, so all I have to do is edit my wrap, this face. That's the way it always worked. Wrap worked on a single face. There's a really cool thing that they just did where now you can wrap a spline surface. So I can come down here, right click, select tangency. It's going to pick all the way around, right click, ta-da. Which really took away the steam of my great trick because I found a workaround, and then they go and they fix it. So bear with me, I'm going to show you my workaround because I'm proud of it. So I'm going to edit my sketch. All you have to do, just like I did earlier, right click, select chain. There's a tool called Fit Spline. And what it's going to do is it's just going to wrap that around the part. Same error, we know what that means. Edit this, pick this face, and it's able to wrap it because that entire surrounding surface is one surface. So they took away one of my great tricks, but I'm really happy with spline surface, so I'm not going to complain. All right, what else do we got? Flex those pipes. When you get a tubing laser, people start trying to find new and interesting ways to use it. one of those new and interesting ways is making cool stuff. So I know Kevin's here. I'm trying to find him one of these. It's a tape dispenser that we did for open house one year. So the silver on the back is where you put the roll of tape. Tape goes through the windshield and we cut it on the grill. And of course, you know, we're from Nebraska, so that's what we have. Okay, so here's what it comes off the tube laser looking like. We put some scores in it so that we could bend up the ends, but this is how it comes off. I wanted to show it in SolidWorks so they could kind of see what I was talking about. So there it is. How did I do that? Well, I've got my tube there. I did my cut, and then I used the flex tool. And it's one that not a lot of people use, but it can be a lot of fun to play around with. Bending, twisting, tapering, stretching, all kinds of fun stuff. You're basically setting up the planes, setting your angle. There's some great stuff on the forums about this. I haven't even scratched the surface with what you can do with it. So if this looks cool to you, jump on the forums, look up the flex tool. It's pretty awesome. Bending a sheet metal tube. Okay, this is a little bit different. This is another cheat, so to speak, because we had somebody that wanted to do something like this. We're going to cut it on the laser, then we're going to bend it, we're going to weld it, and it's going to kind of hold it in place. And it's going to look really cool. So instead of doing it as a tube, I left this smallest gap right there so I could do it as sheet metal, and then that way I could fold and unfold it. So put my cut in, I mirror it. Just so you know, in case you didn't, feature manager tree, once you move the rollback bar, there's a setting in your tools options. You can arrow key up and down through it. I like to do it when I'm checking out what somebody's done with a part, just to see how they built it. So made a cut, mirrored it. Now, because it's sheet metal, I need to cut across those bends. So I flattened it using unfold, and I did these little cuts in here to get it all the way through. Fold it back up. Because it's still sheet metal, I can use sketch bend to roll this into place. So now I have a bent sheet metal tube, and then, this is bad, but to make it look good, I just ran a simple extrude in between the two. Now, the first thing that you'll notice about this, oh, don't do this to me. I had it happen to me in a demo once. I had just gotten a new keyboard, and the keyboard had the little zoom toggle on it. It was when I was at the VAR, and so it was on my desktop. And so I'd take my laptop and I'd go away, but it was still reading the keyboard. So I'd go to start the demo, I'd get everything fired up, and there was the part, and then it would just disappear into space. F, disappear into space. Nothing will freak you out like that, you know, because it would stay there as long as you were moving, so I'm just like really mashing keys and trying to, it was not pretty. So this is cosmetic. You're not going to be able to unfold this now because I sealed it all up. But it's a good looking part, and if I wanted to, I could kick it out as a parasolid and send it to the tube laser. But I would send it to him as a flat. All right. Back to the top. That's exactly what I weld meant. You mean there's more? This one still surprises me. Let's just start a new part. And I'm going to hit the weldment tab. I'm going to start a weldment, do a 3D sketch. Draw a nice long line. D, exit sketch, structural member. Okay, when you install SolidWorks, you're going to have your ANSI inch standard, and it'll have half a dozen different styles, and each of those will have a bunch of different configurations. And it's awesome. But who doesn't want more? You could have half a dozen, or you could have that many. How do you do that? I mean, they're already there for you. You just have to come over to SolidWorks Content, Weldments, pick one you like, hold down Control, click on it, download all those files. I did nothing. I held Control and I clicked, and now I have a whole lot. There are still people that didn't know that. All right, need a new profile. This is a fun one because if you do other stuff, because so many people just think of weldments as steel. You can do more with it. So I went out and I found a drawing file of a wood piece of crown molding. So this is what it looks like, piece of crown molding. And I want to wrap it around my room, so I'm going to do it as a weldment because that's a whole lot easier. First thing I'm going to do is I'm going to be really picky about the layers because I just want that crown molding, so I'm going to turn off everything I don't need. And then because I cheated and I looked ahead, I knew that they were really sloppy about their modeling. So I'm going to clean up a little bit of that by increasing this. It's just going to merge the points. It's not a pretty file. Use one of my standard part templates. There it is. I'm not going to use 2D to 3D. And a lot of what I'm going to do here is going to seem weird, but it will make sense at the end. You've been warned. So everybody knows left to right window, everything inside the window, right to left, anything that it crosses. Select two lines, you hit point, it's going to give you the apparent intersection. I'm going to window select everything from my pop-up. I'm going to make a block. My insertion point, I want this to be right here. Now I've made a block. It kind of turns gray. Just to mess with y'all, I'm going to delete it. And then I'm going to insert it because I want it at the origin. And I want to be able to rotate it. Because I get this, I go horizontal. Now I'm really going to mess with you. Explode the block. Now we're all back to underdefined geometry. Window around all of it, fix. That all seemed really goofy, but the whole idea was I want their geometry in the way I want to see it. It's fully defined. I don't need to add dimensions because I'm buying something stock and off the shelf. So hit D, close that. This is the important part that I often forget. I'm very proud of myself for remembering. Select the sketch, say File, Save As. We're going to save it as a library feature part, and I'm going to drop it into my weldment profiles. It was HC 1014 or something like that, as a library feature part. I will know that I've done this right if there's a little L next to my sketch. So now I can close this. I can add it as a structural member just by changing to that, select the line, right-click, crown molding. All right. Well, why would I do something like that? Because it helps the carpenter. And everybody's using R for recent files, right? Please tell me yes. One of the things that I think a lot of people don't know about is you can pin those and you can kind of arrange them the way you want. So the ones that have been paying really close attention have noticed that I've been going left to right on all of my sample files. They're all pinned, so no matter what I open, those are going to stay at the top. Do that with the projects that you're working on at work so that you always have access to them. Okay, so here's the dining room, and this is all of my crown molding. So now I know exactly what I need to cut. I can map it all out. Here's all my pieces. Here's all my lengths. If I want, I could throw in my angles. Now we're getting to the part where I'm just throwing out ideas and I'm just planting seeds. Don't really have time for full harvest. We're just going to show you the cool stuff. All right, 3D sketch ASAP. This is by far my favorite thing in this entire presentation. This is the coolest thing. My head went boom when I saw it. Sal Lama showed this, and it just changed the way I approach everything. Lids on, we're fine. Going to start a new part. And because we're starting a new part, we're just going to draw the SolidWorks icon for a part. But we're going to do it as a weldment. And to do something like that, we would need a 3D sketch. There's a lot of lines and a lot of geometry going on. Let's see how easy we can make it. Okay. Midpoint line. Anybody using midpoint line? You want to use this, and I'll show you why. Midpoint line, it goes straight to a regular line. And one of the things, I used to work for VAR a long time ago, and I tried to impress upon people to sketch sloppy. You want to be in the ballpark, you want to be close, but don't get hung up on it. Just watch for the clues. You know, I want vertical, I want these aligned, I want to assume these relations. All I did here was I started with a midpoint, and then I got the rough shape. Well, if I do a crossing window and make all those equal, and I'm going to undo that because I want to show you something else. Make all those equal. Don't move your mouse. There's your smart dimension. I can come right over. One dimension, I have a fully defined sketch. And I sketched that really sloppy, you saw. I'm going to extrude it mid-plane because I'm a huge fan of symmetry. I'm going to come over here and I'm just going to say equals. I'm going to grab that dimension. So now, if I change this, everything comes up together. But wait, Todd, we were supposed to be doing a weldment. Now's when it gets fun. Weldment, 3D sketch. The E key is your edge filter. Window around the whole thing. I'm going to check to make sure. If I miss some, just hold down Control, pick up a few more edges. S key, convert entities. E key, I'm going to turn off my edge filter. D key, I'm going to bring the sketch to a close. I'm going to click on that face, and I'm going to hide that body. And there's a 3D sketch. Do you know how long that would take if you were like, line, okay, a line, line? It'd be a nightmare. Draw it all up. You want to see something really cool? Click on this. I change that. It updates. Everything comes from one sketch. Well, we've got the weldment. We might as well throw some pieces on it. So let's do a structural member. I'm not going to do it with the crown molding. I know it would be cool, but we won't. A couple of things that I do when I'm knocking these out. Right-click, create new group. I'm still in the same one. Right-click, new group. This is all going to be under one umbrella. Right-click, new group. Now, the reason I did it this way, and create a new group, is because all of those are like self-standing, so those could be like a sub-assembly. They could weld those and just stack them in the corner. But then I can connect all of these in one shot. And that is one final group. Right-click. I'm done with it. Hide my sketch. Come up here to my cut list. There's all my parts. Do a quick update. I have 16 pieces this size, 2 that size, 6 that size. That's a whole lot of weldment, and that was not very long. I'm still doing good on time. And let's change that to 30. The whole thing updates. That's so cool. I'm not even going to save it. All right. Let's see how much we need to. Okay, we're halfway done, and I'm going to finish the rest of this in 20 minutes. Let's see if we can do it. Odds and ends. Using SolidWorks to tutor math. If your kids are taking any math classes and are getting into conic sections, how do you explain it to them? Well, I'm going to go a different way to get the midpoint line. Come up here, grab my midpoint line. Bring you all the way down to here. Start another line. And it doesn't have to be perfect. Just has to be close. Change this into construction. I'm going to revolve it. Yes, please. Okay. All a conic section is how a plane intersects two cones. So a circle is a special ellipse, is what they would call it. Go straight down. There's your conic section. When you rotate it a little bit, there's an ellipse. Rotate it a little bit more. There's a parabola. Bring it out, conic section. There's your hyperbola. Hyperbola, parabola, ellipse, and the circle's a special ellipse. You now understand conic sections. Congratulations. I won't ask you for the equations. It's okay. Combine, not just for plowing fields. Some of the new stuff that we saw this week really made me want to go back to this. Sometimes this is all you get. It's an old sketch, and it doesn't give you all the dimensions you need. How do you work around it? Well, what you can do is break it up, use sketch picture, insert tool, sketch picture, line them up. You can scale them to get it to the correct size, and then you can just trace it. And when they showed the pen today, I was like, oh man, that would have been so nice for this. Just pen trace, boom. So there's that. Went one too far. There's the profile, and then I use the combine tool with the intersect. Everywhere that those two solids intersected, this is what's left. So top view, front view, and if we hide these two, we have a very well-drawn chassis. And it was pretty easy. And just to give you an idea, this is almost 10 years old. I did this back when I was at the bar. All right. Multi-body makes it happen. That was one look at combine. Let's take a look at another one. I'm a big bike guy. I like bike stuff, and I did some bar ends for a friend of mine. So they're basically just cap the ends of your handlebars so that you don't scratch stuff up or hurt yourself. Start out with a simple revolve. To get that diamond, he wanted to have a ball end mill do it. Well, it was really easy to create the shape. But then it was even easier to just come in with a fillet and round all that over. When I do the combine, I just use that as a cutting tool. So it was all at once, took it all out. Simple part. It looks really complex, but it's just a simple sketch, extrude, fillet it over, subtract, multi-body. There's so much stuff that you can do with multi-bodies. Do you really think this will bend? I work in a metal shop. I have heard the other side of press brake operators. because I have created stuff that doesn't bend well. And they are not shy, they'll let you know. So I found this on the forums. Gerald Davis from Colorado did this a while back. And it's just the parts of a press brake. That looks fine. Or does it? Right about there is where it hits and starts to make noise, and then it really does weird things to the part. This is a special thing that he did with multiple parts to do the animation to make it look cool. All you need is the top and the bottom as an assembly. You drop your part in there, you made it to the bottom of the V die, and you bring this down and see if it's going to hit the back end of it. We're gaining speed. We got 15 minutes. I think I can do it. Sensing a pattern here. I might. Ooh, it might. We might be tight, so I'm going to really kick it into overdrive. All right, what is all this? It's a build list for a room. Here's my floor plan. And when you build, you usually want your 2x4 16 on center. And when I rebuild this, I want a good count on my 2x4s. How did I do it? Well, I'm going to open up this part, and what I did was I drew the 2x4, I drew a small hole in it, and I patterned it. But I didn't use your normal pattern, it's just a standard linear pattern, but I did up to reference. I put a plane at the end, and then I said, okay, make them 1'4" apart, and as the length of this changes, it's going to adjust to make sure that I always have 16 inches between them away from that plane. And the reason I did a plane, this is just really random trivia for you here. Say no. Let's see if either of these has close parts. These are closer than 16. I want to have this one here because when they're hanging drywall, they're going to want that extra piece there. So you're going to have an extra one. So I set this up for that stagger. All right. Going back to the top, got 2 categories left. I'm going to fly. Do you really want to type all that every time? No, I don't. So, what I'm going to do, bless you, what I'm going to do is I'm going to start a new drawing. And just want you to see a little bit of what's going on, so I'm going to just do a quick grab of this. And then I'm going to jump back to SolidWorks. And I'm going to bring this part in. Drop it right there. Title block filled out. This is something that you should be doing. I just wanted to show you some of the things that I did. So, department, description, part number, weight, project. Let's see, what else do I have in here? I have file location. Get down into here, I have section area. This is for determining how much of a sheet we're going to use. How much space is it going to take up on a sheet? Total perimeter. That's for the laser. We can calculate laser time. You know, if it's really thin, we're doing 1,500 inches per minute. How much can we cut out? Total surface area. If we're going to powder coat the part, we need to know how much powder is going to be used. We get our price from that. All of that came in just by dropping the part in, because the part had the custom properties to it. So, let's have some fun and look at that. Keeping tabs on your properties. There was a great presentation right before lunch, and go hit Javelin's website. It was Scott Ellery and Alan Topic, and they did one on custom properties, and it was amazing. This is a purchase part that I have in my assembly. Description, material, I don't need to worry about that because it's purchased. Finish, don't need to worry about that. Here's which department, and you'll notice right below it, this is changing. So if it's a national manufacturing part, it's going to go to one of these pieces of equipment. If it's for the company, we'll list the customer. But I also have vendor. So I can select from a number of vendors, put in their part number and their cost so I can cross-reference that later. How did I get that? Bob the Custom Property Tab Builder. So I do a lot with property tabs, so I have it at ready access. I'm not going to get into this. I'm going to say dig into it yourself. Everything on the far left is your tools. You drop them here in the middle. Once they're dropped there, this is where you customize them. Just to give you a quick taste, that part one that we were just looking at, here's the description, just dragging stuff over. So this was the custom one, the kind of funky. This was just a radio button, brought it over. This is where I customize it. Here's the name, here's the quantity, here's the values. When I hit advanced options, if one is selected, it's going to display this property. If another one's selected, it'll change that. Project is just a drop-down list. I have a text file on the network that it grabs all the information from. I'm just throwing out things that you guys need to dig into because they're huge time savers. Do I want to exit without saving? Yes, I do. All right. Nope. Manipulating metadata. Why do I put all that stuff in there? Because I need it. So, I'm going to show my table. I have two different bill of materials. I have a standard one that we throw on our prints that has description, quantity, part number, stuff like that. But I have another one I use internally that has vendor, vendor number, cost, so that I can have a column here that has a running total. So if I have two of these screws that are a penny each, that's 2 cents. I just add a column, set up equations, and then I have a total cost, where this is just an equation that sums up that column. So there's so much that you can do with these. Dig into it. Hide the table. While I've got this up, might as well show a little bit of assembly visualization. Dig into this. That's all I'm going to say. Right now I have it showing what's internal and what's external, or purchase parts. There's so much you can do with this to speed up your assemblies. Start by not typing. I can't encourage this enough. So I've got all these custom properties, and you could open up that pane and fill all that out, or you could have all that in your templates. So if I go to start a new template, and I do a lot with extrusion, I'll put the sketch in there because I know what size it is, and these are just aircraft grade aluminum angles that come in a variety of sizes. So in the template, not only do I have a sketch, but I have a design table so that when I drop this in, I can pick my size and have my finished part. And it has all that metadata in there. So like this one is just a standard name slip 2020 8020, thank you. One of their standard parts. So I can come in here. I've got the sketch already. Just hit extrude. Pull that out. If I want to get fancy, I can go mid-plane and go crazy with it. So my part's done, and I have all the information. This is the description, material, finish. I'm going to use it for one of my fermentation cabinets, and it has all the vendor info. Everything's in there. I didn't type in a thing. All right. Let's see if we can do a bathtub in 6 minutes. Rub-a-dub-dub, let's model a tub. All right, we're going to start a new part. Use one of my standard templates. Top plane. A lot of people don't think of the slot as a tool for drawing things other than slots. It works great for drawing other stuff as well that might have that shape. In case you don't know this, when you dimension, you can grab the outside by holding shift. That's one that I always throw out there because there's people that don't know. I like to help them out. I'm going to drag it up, get closer to this, and it snaps to it. Let's go about 18. Looks like a comfy tub, right? Okay, let's add some draft to it. Now it's just cruel torture, I'm sorry. Let's try that. The only problem with this looks great, but now it's not going to fit in that section of the room unless we knock the walls out or do something weird with it. So what we're going to do is, instead of going from the sketch plane, I'm going to jump it up the height of the tub. I'll flip the direction, and then I'll flip the draft the other way. Now that looks like a much better tub. It's going to fit in the space. It's got the draft. The only thing that I don't like about it right now is that I have 2 dimensions in here. So instead of going blind, I'm going to go up to surface, and I'm going to grab that top plane. The reason I did that is because then now I can grab this and change it however I want, and it's going to stay attached to the floor. This gets into paying attention to your cursor. I'm going to click right here, pop up, select other, click right here, pop up, there's my fillet. I'm going to type in 3, hit enter, right click, didn't move my mouse at all. Click on that face, shell, type in 1, move down, right click, shell. Pay attention to your cursor. When you move too much, you're going to lose it. There's our bathtub. Let's fill it. Top plane, if you remember, control, drag, make a copy. Say OK. I'm going to use this as my water line. Use intersect, hit that. Create an internal region. You can do create both. You could do either or. I'm creating the internal region. And the one thing I'm going to do is uncheck merge result. Say OK. Should have 2 solid bodies now. The tub and the water. Just so I know, that's my water. Tub's full. How much water do we have? Let's just go to evaluate. Mass properties, right there. Everybody knows what that means, right? I mean, you're going to stop on the way home and pick up 231 cubic inches of milk, right? Oh, okay. Let's do this. Document properties, units, custom. Let's just change this to US gallons so that it makes more sense. Recalculate, 65 gallons. Okay, we know how much water there is. But do we have that big of a water heater? Let's say we only have a 50-gallon water heater. Well, let's add a sensor for the volume of my water. And if you look, it says 54 imperial gallons. There's a glitch. There's an SPR right now. I'm watching it like a hawk. I'm going to say is less than 42. I'll let someone answer that. Why? Okay. The answer to life, the universe, and everything? All right. So I'm after that. My sensor is showing 54 right now. I grab my plane, move it around, and that'll get me close. I can fine-tune my dimension if I want, but now I know about where I need to be. Now the tub's full. We got hot water. Time to mix a drink. Let this in no way reflect some of the people that I work with. We had someone that wanted a machined drink jigger. I was like, sounds cool. I'm for it. So what I did was I modeled 2 separate pieces that would screw together because he wanted 3 ounces on one side, 2 ounces on the other. And here's how I did it. So we'll open up one side. I'm going to roll this up. Simple boss. I created this other part. I'm going to hide this. I created this as a separate part the same way that I did the combines and the tub. I made the shape, and I brought it until I had an ounce. And then I did another one, ounce, another one, ounce, combined them all to make this, saved that part, put it in here, did a combine to subtract it out, did the rest of the machine work, and there's my drink. I have 2 ounces on one side, 3 ounces on the other. And we're done. Drain the tub, it's over. Now, does anybody want to know how to do this? It is super easy. I can do it in 30 seconds. This one's a little bit different. I did this as an assembly. I have the tub as one part, the water is another part. Do a motion study, pop it out to about 5 seconds. We have a really fast draining tub. I grab the water, drop it out the bottom, calculate. The way the water's set up, I did a square solid, and then I did a 0 offset surface on the inside of the tub, subtracted that out, so that's all that's left. So as that moves down, it stays with that surface. And so now I can play a draining tub. The duct came from 3D Content Central. So we did it. It is 2:31. Don't forget to fill out your surveys. I think my email's in the book. The book has every tip I did. Probably some more. I may have skipped some, but thank you.